Thank you. It's great to see different faces here to learn the blockchain technology. And I'm actually the third colleague from PolyU introducing something that are interesting. So I will introduce peer-to-peer networking. Is another fundamental building block of blockchain technology. And if you have any questions, so don't hesitate to interrupt me. So the first thing, what I will introduce, the first one will be the history of P2P networks with some historical, very famous projects. And second one, we will discuss the network layer and the network conditions that the blockchain operates on. So that will be the mostly operate on the decentralized peer-to-peer networking. And third one, I will talk about the traditional Web2 network overlays, the advantages and the disadvantages, and the Web3 network overlays, so especially for blockchain. And I will also discuss attacks on how to address along with the underlying threat model. So actually that is, so following the advantages and the disadvantages of Web2 and Web3 networks, okay? And due to the disadvantages, there will be a lot of attacks. And we may introduce some measures to mitigate the attacks. So the first one, the historical P2P projects. This one, ARPANET, is a very famous project. So actually, is the first operational packet switching network. That is also the building block of our current internet through packet switching. And what is packet switching? I will introduce it later, but basically it will be from myself, from the sender to the receiver, how can the data be transmitted? And it was developed in the late 1960s by DAPRA, the Defense Advanced Research Projects Agency, and later the foundation of the modern internet, as I just said. So it's a very basic protocol of packet switching. So suppose I'm transmitting a large amount of data to you. So how can I transmit such data? So I cannot say, so it's just like when you are downloading some file from the internet. If the file is very large, then you need to divide the data into several pieces and receive the data, and finally ensemble the data into, ensemble the packets, fragments into the original data and check the integrity, etc. So actually this protocol is the foundation of our current modern internet. So what is packet switching? So it's basically what we have said. So you see the model of data transmission in which a message is broken into a number of parts that are sent independently. So it's something like I send the data to you, very large scale data, and I need to divide the data into packets or fragments, okay? And you will receive, and the different fragments will be sent to you independently, and you will receive a lot of packages, okay? And you can assemble the packages. So suppose you are an internet player and you have received a lot of packets from others. Of course, you need to identify whether each packet is from me or others, right? And of course, we have some mechanisms. So for example, include the destination address and the receiver into the packet so that you or the receiver can recognize there's different packets from the same sender. And the packets are sent over whatever route is optimal. So it's like our modern internet. So if you have, I'm not sure whether you have run the computer network or communication network. So our modern network actually consists of a lot of switchers and routers, okay? When you are sending some data to another, so it's just like you have a IP address and you are sending some data to others, and you are going to find you do not need to find a way for the packet, right? That's due to the packet switching protocol. The internet can automatically select the optimal route from the sender to the receiver. And the packets are reassembled at the destination, is what I just said. So you are the receiver and you have received a lot of packets, not necessary from me. And you can recognize the sender and assemble the package from the same sender so as to restore the original data. So as packet switching, you can see this diagram. The message will be divided into different packets, and the packets will consist of the header and the payload. So the header basically contains the destination information, the receiver, and there can be some encryption mechanism if you would like the message to be encrypted. And the payload will be the data that you are sending, okay? So it's like if you are sending a very long letter to your friends, such a letter will be divided into different packets, and the data will be stored into the payload. And so by saying finding the optimal route, so you can see this diagram, the green circles will be the sender and the receiver, and inside we have a lot of other nodes in red circles. So for example, the left node is sending some data to the right node. Of course, there are a lot of passes or routes. Currently, we can find two routes, right? The first one is red lines. And of course, suppose, in our modern internet, the network may be unreliable. So it means, so for example, some nodes can crash, and there is still another way or route from the source node to the destination node. Of course, the node here refers to the different network infrastructure devices like the routers, switchers, etc. Okay. And regarding peer-to-peer network, so just now I've just reviewed the historical internet protocol, that is the packet switching strategies. And regarding peer-to-peer network, so actually peer-to-peer network is a decentralized form of the network structure. So what we just showed is the sender receiver. You see, they are the end users of the internet. And we can find we can regard them as the end user, and the middle part will be the internet provider or the internet infrastructure. So including the switchers and the routers, etc. But for peer-to-peer network, it is a decentralized form of the network structure. So it means the inside part, the inside node will also be end users. Okay, so you can regard that the end users are connected with each other to form a decentralized network. And different from the client-server model, most of our current systems are employing client-server model. It's just like when you are using the Meta or X, okay? So the client will be yourself, your mobile phone, your tablets, etc. And the server will be the Facebook, the Meta servers, okay? So they will such servers will store your data. That is a client-server model. So for peer-to-peer network or model, all the nodes are equal participants. It means when you are using your mobile phone as the end devices, you are a client and you are also a server. Okay, you can provide the, you can act as the middle node to transmit the packets sent by others, and also you can act as a sender, that is the client. Okay, you can also send some packets to others, and other users can be regarded as the nodes in the middle. And the data is shared directly between the system without a central server. So, also just the example we showed, we said before. So you have the Meta server, and you have your mobile phone as a client. So previously, so you have the client server, but now but in peer-to-peer network, all the clients are connected with each other. And if you have the data that you would like to transfer to your friend, for example, so you can send a direct or instant data packet to your friend. And peers contribute resources, including bandwidth, storage space, and processing power. So, how the peers can contribute resources? That is bandwidth. So it's something like you are transmitting some data to others. So you need to use your bandwidth. Okay. So at a certain amount of time, you can only transmit a certain amount of data at maximum. And when you are transmitting the packets from others, so you are using your bandwidth. And of course, sometimes the message will be put into your incoming message buffer. Okay, so there will be some places that will store the messages from others temporarily. So you need to consume the storage spaces. And also processing power. So just now we say in packet switching protocol, an optimal route needs to be selected for every packet. Okay. And in our peer-to-peer network, everyone is identical. And for each node or each peer, you need to consume some processing power to decide the next step for each packet. Okay, so that needs the processing power for scheduling of the packets. So here, in peer-to-peer network, sometimes we say nodes, sometimes we say peers. So why we say we call the nodes as peers is because all the peers are identical. They play the same functions. Okay. So for now, any questions? Okay. So it's very good. So, I mean, historical network models are very important, and the concept of peer-to-peer network is also very important because it's the foundation of our current blockchain systems. So actually, peer-to-peer network is not new. So it's something like, I'm not sure whether you know, we say that the computer science research has a cycle. I mean, for every around 14 years, we will do the same thing. So for example, 14 years ago, we are doing the peer-to-peer networking and application, and nowadays we are doing it again. So, but we have a different name, that will be the blockchain. So, but of course, there are something new in the blockchain technology. And also there are some historical peer-to-peer applications. So the first one will be Napster. It's a very famous blockchain project launched in before 2000. It's a very popular P2P platform that is used to share music, videos, etc. Okay, so as that, so for example, the movie player, the movie producer, they have produced a lot of movies, and at that time, there are very few ways to deliver the movies to the end users. And Napster is such a platform for many people all around the world to share the video and the music, etc. And in Napster, there is a central server for indexing and the peer-to-peer network for transfers. So it's something like I just said, in this classroom, every one of you are connected in a peer-to-peer way, and you would like to share a video, to someone else. So, and the central server is, in this system, central server is needed for indexing. What does it mean? It means you need to index which nodes have which file. It's something like Alice have a movie with ID something, and Bob has another movie with ID something. And when a node is searching a movie with some ID, so you need to have the index server to locate the file that have stored the movie. And P2P for transfer, so it means whenever a resource or data is found, so there will be a connection, direct connection between the two users for data transfer. So you will see, even in such a P2P system, we have the combination of centralized server and peer-to-peer transfer. And it was shut down in 2001 due to legal issues. So it's a history actually. So it's because there was a band called Metallica, should be Metallica, and it has produced some new music, okay, some new songs. But before the band delivering such a song, the song was getting very popular in the Napster. And of course, it violates the copyright protection laws. And the band Metallica has put such a system into the court. And finally, the US government has decided to shut down such a platform. So it's because our perception on copyright protection, and so nowadays such a system has been shut down. And I think in early 2000, similar peer-to-peer data sharing platform were very popular. And so you can see for Napster system, it's something like you have the index server. So yeah.
I noticed that the Napster was closed 2020, 2001, and is like the Onion network was launched around this epoch, like 2002 or 3. Were they connected? Like, was one project the base to the other? Do you know something about it?
So what is the other project?
Onion network.
Onion network.
Yeah.
So Onion network is basically is primarily designed for anonymity. So it's not primarily designed for peer-to-peer data sharing, I have to say. Okay. So I mean nowadays, for example, if you are surfing on the internet and you dare not to release your data. So because some large scale companies may leverage your data for certain purposes, and the Onion network was designed for the anonymity purpose rather than for peer-to-peer data sharing. Sorry? Yeah, exactly. So I have to say there are different technologies. Yeah. And okay, so if you look at the system architecture, so you will see there are some clients and the index server. And basically the index server will only be responsible to store which data are located at which client, okay? And when there is a request from a particular client, so for example, the client is Lim, and it is requesting a text editor, Sublime, and the index server will receive such a request and will locate the node that has such a piece of data, and it will then establish a direct connection between the two peers or the two clients. And so that the client submitting the request can download the file from the server in yellow circle. Actually, the node in the yellow circle currently is serving as a server, right? So it is outputting data. It is sending the data to another one. That is Napster system architecture. And then also we have the Limwire, is also called Nuttler. So in Nuttler, so it can avoid the central indexing server. So each node will serve as both a client and a server, and there will be no central server. So different from the Napster. So you will see we have no index server, and because we have no index server, it will be very difficult for a node to know which nodes have a particular piece of data, right? So it has suffered from network flooding issue. So it means by locating the node that has a certain piece of data, it needs to query all the connected nodes for files. So it's something like in this classroom, if you like a movie, okay, with a particular ID, then you send a message to everyone to ask whether you have a movie with the ID, whether you have the movie with the ID. So it will be very time consuming, and it will lead to network flooding. It means make the network full of messages that are beyond the capacity of the network. And we again peer connection to the network via boot nodes. So the boot node is another very important concept actually in blockchain technology. Boot node is something like the nodes that was established for network establishment. It's something like I am the, yeah. So you have a question?
Yeah,
Okay.
I was hoping you could discuss more on the peer discovery, right? I guess you're going into that, into distributed hash tables and so forth? Or
Yeah,
not?
exactly.
Okay, cool.
Yeah, the boot node is, so for example, the established, when the Bitcoin network was established, there is a boot node. It means inside the Bitcoin source code, when you would like to connect it to the Bitcoin network, you will ask the boot node for a set of nodes that you would like to connect to. So that you can, so it's something like I ask the boot node for a set of nodes that are in the network, and I can connect with some of the nodes returned to me. And it was also ordered to shut down in 2010 by United States court, also due to network traffic problem and also due to copyright problem. So it's because whenever you have a request, you need to send the query to all the connected nodes. So it will make the network very congested and very heavy workload to the internet, and makes the internet with very low efficiency. And let's have a comparison, a comprehensive comparison between the client-server model or network with the peer-to-peer model or network. So again, the client-server model is Meta or X. Okay, you have the centralized platform and the databases providing the services, and you as the end devices or the client will enjoy the services provided by the servers. And for peer-to-peer network, every nodes are connected as identical peers and provide and enjoy services with each other. The first one, structure, client-server model or network is very centralized. One or more central servers control the network. Okay, so again, so if we talk about the Web3, okay, it's also the aim is also to decentralize the whole network and make the data value back to the end user. It's something like when you have some post on Meta or Twitter or X, the data will have some value. And actually, currently, the value are owned by the companies, Meta or X. And Web3 is going to make the value of the data back to the end user. So it's also due to the curse of the centralized client-server model. And for peer, yeah.
Yes, hello, Marcus here. The whole peer-to-peer architecture kind of reminds me of how IPFS is structured. Does IPFS use the peer-to-peer architecture to decentralize the whole process of storing files, more or less?
Yeah, exactly. IPFS, so is very famous decentralized data storage network, and so should be the lab protocol. Is the lab protocol lab has developed another token called Filecoin on top of IPFS. So I can say that IPFS or Filecoin is a very important application of blockchain, and yeah. So in the field of data storage or data infrastructure, so peer-to-peer IPFS is actually employing the peer-to-peer model. Yeah. Thank you.
Thank you.
Yeah.
My question might be a bit naive. It's about LimeWire. As you said, there was not central server. Or can you shut down a decentralized infrastructure?
Sorry. So yeah, may I beg your question again?
Yep, it was about LimeWire. You said it was shut down in 2010, but if there is no central server, how can you shut down the thing?
Such a system actually is decentralized. It was employing the peer-to-peer network or structure, but it has a company controlling such a system. So I mean, to issuing the software and the licenses, etc. So such a company should be located in US. So the US preserves the right to shut down such a company. Yeah.
But it was also because they were able to track the nodes that were running LimeWire.
Yeah,
One question here.
yeah.
Hello. I have a question regarding the peers by, for example, a government. Is it possible maybe to attack with a DDoS into the, for example, in a blockchain to the validators, so they get completely with a lot of traffic and put down the integrity, the blockchain itself?
So do you mean, can we perform DDoS attack
Yeah.
onto the peer-to-peer network or blockchain? Such a question, I will mention it later on, okay? So I will exactly mention the attack measures and measures to mitigate such attacks, okay?
Hey, so for LimeWire, all the statements you stated, they collapsed, but they were able to relaunch in 2022. Do you know why they were able to relaunch? Because they launched their own crypto token, they raised $17 million to restart LimeWire. So they were once collapsed and now they rebuild. How were they able to rebuild without some of the restrictions that they previously had?
Okay, I have to say the relaunch is partially due to the popularity of blockchain technology. So in this way, I mean, a lot of companies or investors, they have the money and they regard such a project to be successful in the past. So they would like to invest some money to such a project. And of course, when they were relaunched, such a project was relaunched, the company has to take care of the regulation and legal issues. I mean, due to the popularity of blockchain technology, in short. Yeah. Okay. Let's continue. Just now I mentioned I compare the structure between the difference of client-server network and peer-to-peer network regarding structure. For peer-to-peer network, it is decentralized. It means there is no central server that can control the network, and all the nodes participate equally. They are with equal responsibilities. That's why we call the nodes as peers. But that will be the ideal case. So in the ideal case, in a decentralized network, all the nodes are identical. But in our real-world implementation of some projects, some nodes may not be identical. It's something like the mining pool in Bitcoin, like the bootstrap nodes. They have special responsibilities. And regarding data flows, in client-server model, the servers provide the data to the client. Okay, so it means the client provides the services, not only the data. Okay, so when you are using the Meta, okay, when you are requesting the data from Meta, requesting the posts, text, images, etc. from the server, Meta server, so Meta server will respond to you. And the data flow in peer-to-peer network, the peers will directly share the data with each other. Okay, there will be a direct connection between two peers, so that the data sharing can be made. And regarding resource management, in client-server network, the servers manage resources and control the access. So it's something like when you are banned from some central server, like the Meta, okay? So your account was banned by Meta or X, then you can no longer enjoy the services or get the data from Meta or X. And in peer-to-peer network, peers contribute resources including bandwidth, storage, and processing power, okay? Rather than the server, okay? The peers or the nodes will contribute such resources. And regarding scalability, the client-server model can be limited by server capacity. So that's why in many modern applications, they will employ multiple servers, or they will use more servers when the network traffic is high. So for example, when you are using the Amazon Web Services, you can select the elastic compute, okay, and it can decide the amount of resources, that is the number of physical devices for your applications. And regarding peer-to-peer network, so the scalability is the system will be highly scalable due to the distribution of resources. So it's just like the Bitcoin network. So the Bitcoin network can moderate as many nodes as possible. Okay, so currently there will be the nodes from all around the world, right? So it is very scalable. And when you are talking about the central services like Google, so you will need different servers located at different regions. Like in Asia Pacific region, we need a server. In East US, West US, we need different servers. So you need to have more physical machines to serve more clients in different regions. And regarding security, client server network is centralized, and it will suffer from single point of failure, and we will have centralized security measure. Okay, so single point of failure means when the server crashes, and then the clients can no longer enjoy the services. Okay, when you are visiting some websites, so sometimes you may get 404 or 400, etc. And such errors is due to the single point of failure. I mean, it can be because of the failure of the network structure. It can also be because of the failure of the servers providing the services. And regarding peer-to-peer network, there are many potential for some security issues. I mean, there will be different security measures, okay, for decentralized network. So, for example, when we are talking about our current blockchain system like Bitcoin, Ethereum, Hyperledger Fabric, etc., we are always talking about Byzantine fault tolerance. Okay, so such an issue will never resist. Such an issue is not available in centralized system like a client server network. And there can also be some malware depending on how it is implemented. Like you can provide your own Bitcoin client. Okay, you can develop your own Bitcoin client, but such a Bitcoin client can be malware. Okay, so it's not officially provided, but you can claim that it is fast. It is faster, right? Such a software can be a malware. And yeah, thank you. Let's compare the centralized and the decentralized network. So just now we have compared the client-server model and the peer-to-peer model. And the centralized and the decentralized network actually, so that is a representative of client-server model and the peer-to-peer model. So in centralized network or client-server, we have the client, that will be the red circle, and we have the server, that will be the green circle. And when the server shuts down, okay, so the green circle shuts down, and all the other clients will no longer able to enjoy the services. So that is a single point of failure in centralized network or client server model. And in decentralized network, so the peers are identical and they provide and enjoy services with each other. And suppose the dark red node is broken or fails, and the yellow nodes can still enjoy the services in the decentralized network. Okay, it can still transfer the data packets to others, and can still receive the data packets from others. So that is a major difference between centralized and a decentralized network. It means it is centralized network will suffer from single point of failure, but decentralized network will not. And there are a lot of advantages of decentralized network, and of course, centralized network. So first one, there is no privileged nodes. So it's like when we are talking about centralized network, the Meta server can shut down your service, can close your service at any time. So it's like Donald Trump. So his Twitter or X account was closed, right? So I mean, it may be because of some legal issues, but the X server will be the privileged node. But in decentralized network, we will not have such an issue. And there will be less bottleneck with bandwidth. So just now, students talk about the DDoS attack. Is an attack leveraging the limited bandwidth of any node. So it's something like when you have a computer and you are connected to the internet, the bandwidth will be limited, will always be limited. Okay, you cannot have unlimited bandwidth. And we have a lot of nodes sending requests to you, and of course, you will not be able to process all the requests. And your computer or your server may shut down due to limited bandwidth, and you cannot serve the honest nodes anymore. And that is also, we call the DOS resistant, okay? So in decentralized network, we will not suffer from DOS attack anymore. And there is no centralized infrastructure necessary, okay? We will no longer need centralized infrastructure to provide services to us. We, as citizens or end users, can provide services with each other. But an exception will be the internet. So the current internet actually is centralized, I have to say. It's because the key routers will be provided by specific stakeholders and organizations, so making the current internet we are using centralized. So that is also the centralized internet is also to make the internet decentralized is also a mission of Web3 or blockchain-based Web3. And besides the advantages, decentralized network will have some disadvantages. Every coin has two sides. So the first disadvantage is because it is permissionless, a node can share malicious resources. It's something like just now, you would like a movie, and your friends or someone you do not know that has a movie can send you some something that that was mistaken on purpose, or something that is not needed by you. And second one, latency. So that is also the advantage of centralized system. Centralized system is more or less always faster than the decentralized system, because you have the very stable infrastructure providing the services. And for decentralized services or decentralized system, when you are going to send a package to your friend, the nodes in the middle providing the routing services need to do the selection. And of course, not all the nodes have very powerful, have a lot of computation power, so the packets may be delayed and the latency will be long. So for example, the current, so Bitcoin mining, so when you have found a valid block and you would like to disseminate or broadcast your block all around the world, so it will take a long time, okay? So why the Bitcoin, the interval, so for around every 10 minutes, a Bitcoin block can be proposed. It's also due to the latency. So 10 minutes were set due to the latency of decentralized network. And it will be very difficult to regulate illicit activity. So in historical peer-to-peer connection, you are talking about data sharing, music, video. There will be a lot of illicit activities. That's also why the Capstone and the Capstone was shut down. Okay, there will be different regulations in different regions regarding copyright, and it will be very difficult to regulate such illegal or illicit activities. And the network will be limited by nodes with the weakest hardware. Okay, so if we are talking about the network that has some competition, okay, or such a decentralized network, the decentralized application rely on every node to join, like consensus. Okay, if we are talking about consensus in a federated blockchain, then you need every node to join such a consensus protocol. And of course, the performance will be dependent on the nodes with the weakest of hardware. So that is the processing power, storage space, etc. That is also another disadvantage of decentralized network. And okay, so in decentralized network, how a piece of data can be transmitted all around the network is something like when you have found a valid Bitcoin block, how you can transmit such a Bitcoin block to all around the world. Okay, that is, so if you are talking about the very classic protocol, that will be the gossip protocol. So what will be the way? So can you think out a way? So if you found the valid Bitcoin block, how can you disseminate such a block to all the others? Okay, so a very initial idea can be the gossip protocol. I mean, an intuitive way will be, whenever I find a block, I will send my block to everyone that was connected. Okay, so suppose I was connected with Alice, Bob, Emma, Cindy, etc. I will send such a block to everyone. Okay, everyone as far as I can. And when Alice received such a block, okay, she or he will do the same thing. She or he will broadcast such a block to every node that was connected by Alice, including me. Okay, and then suppose Bob is a neighbor of Alice, then Bob will also send such a block to Alice, possibly including me, and it will lead to network congestion. So that is also the disadvantage of the limware. So a smarter way or more intelligent way will be gossip protocol. So it means I will send at each time point, at each time step, I will only send the block to one of my neighbor. Okay, suppose so for example, the node 1 has found a block 45. So it has 2 connections. Okay, node 2 and node 3. So at each time step, node 1 will send such a block to either 2 or 3. Okay, it will not send such a block to 2 or 3 at the same time. And the selection will be randomized. And of course, when node 2 has received, it will send such a block to its neighbor, that is node 1 and node 4. So it will choose node 1 and node 4. And so when such a process is randomized, then finally the block can be disseminated all around the network, and the efficiency will be a little bit higher than the naive approach. So actually, the gossip protocol comes from a story about office rumor. Okay, so for example, I have saying that Alice has some affairs. Okay, and I'm going to the water room. At every time step, I go to the water room and I find my friend, and I talk to him or her and send such a rumor to him or her, and the water room will be a place for the gossiping. Okay, gossiping of some messages. And finally, so I mean, if we are doing the gossip for some time, then such a message will be disseminated all around the network. Actually, regarding, so just now we have talked about the gossip protocol, and the gossip protocol is a very advanced way, I have to say, for message broadcasting in decentralized network or peer-to-peer network. So actually, it's a structured protocol. And the naive way, so it means I will send what I have to everyone that was connected to me. That is the naive way. So you will see we have some structured methods or structured network, and also we have some naive way or unstructured network. They all belong to peer-to-peer network. And if we are talking about the current blockchain network, I have to say it's kind of structured. Okay. And regarding the difference between structured and unstructured peer-to-peer network, if you are talking about the organization, so you will see the nodes in structured peer-to-peer network are organized following specific protocols and structures. Okay, So it's not like a limware. So the network is unstructured. So whenever you would like something, you just send your request to all the nodes you are connected. And in structured network, so you will use some special techniques like distributed hash tables to locate the data and do the request. And the nodes will also be connected in a structured way, okay? So for example, in Bitcoin or Ethereum network, you will have the bootstrap node, okay? Such a node actually is a way of node organization. And regarding unstructured peer-to-peer network, the nodes will be connected in an ad hoc manner without any particular organization. So it means whenever you are joining the network, you are connected with whatever you know, okay? And such a network will be ad hoc. So why we say it is ad hoc is another concept in computer network, okay? So for ad hoc network, so it's to make so I think it originates from the wireless sensor network. So you know wireless sensors can be connected to the network from time to time, and they may leave from time to time. And the wireless sensor network demand such an unstructured peer-to-peer network for data dissemination. But for regarding our blockchain system, we would like higher performance. We would like the system to be stable, okay? So we have a kind of structured network. And regarding search efficiency, the structured peer-to-peer network, the search efficiency will be higher due to the structured nature. So for example, the distributed hash table, so is a way to locate the data that has been owned by each node. So if the peer-to-peer network is maintaining a distributed hash table, so every node will be able to locate the data. So locate which nodes have which data, so that the search efficiency will be higher. And regarding unstructured peer-to-peer network, the search efficiency may be less efficient and can involve flooding the network. So it means in unstructured peer-to-peer network, whenever you have a data request, you will just send such a request to everyone you are connected, okay? And you do not know which nodes has the data you would like. And you just send the request purposely, so the network will be flooded or congested. And regarding flexibility, of course, structured peer-to-peer network will be less flexible because changes in topology require restructuring. Okay, so for example, in Bitcoin network, we say that we have some bootstrapping nodes. And if a bootstrap node leaves, so it will lead to very severe challenging issues, okay? So the newly joining nodes will no longer know which nodes to be connected to if a bootstrap node is not there. So the changes to the network topology will be unflexible. I mean, less flexible, but still flexible than the centralized network. And regarding unstructured peer-to-peer network, it will be highly flexible as nodes can freely join, leave, and reorganize. So that's why we say the nodes are connected in an ad hoc way. So we talk, yeah.
In a structured P2P network, also nodes can disappear. And then the distributed hash table will be updated definitely. So what's the difference? I'm not able to really recognize.
Sorry?
Yeah. The difference between a structured and unstructured P2P network is very thin, I guess, or what? Because say IPFS, which is based upon distributed hash table, one node can go down. That was the property of the P2P network, that if one node goes down, nothing is affected. It still works. Services will be available, data will be available.
Yeah.
So how it is different, I'm not able to understand.
Okay. So like you just mentioned the IPFS. The IPFS is structured peer-to-peer network. So it's structured in a way that all the nodes are confronting to the IPFS protocol. So for example, if you are IPFS storage node, you would like to join the IPFS network to store the data from others to enjoy the tokens. Then you need to deposit some tokens into the IPFS network. And whenever other users, when they are requesting some data from you that you claim that you have, and you have not provided such services, then the tokens deposited by you will be lost, okay? So will be given back to the IPFS network. So you will see it is structured in a way that you will bear some cost when you leave, okay? So it means you cannot join or leave the network freely. So that is structured. Also, in a lot of blockchains like Bitcoin or Ethereum, they have the bootstrapping node. So it means there will be the nodes that are somehow always there. So when you are joining the Bitcoin or Ethereum network, you're always first connected to such bootstrapping node. And the bootstrapping node will be the infrastructure permanent in such structured peer-to-peer network, okay?
Yeah, so incentive, we penalize, kind of penalization is happening if the node goes down. So that is happening at the service and that design. But at P2P level, technically any node can go down anytime, and other clients are able to fetch data or the service from other different clients, which is live.
Yeah.
Is that correct?
Yeah, exactly.
Okay, and I also want to know any other protocol which is a structured P2P network than distributed hash table?
Distributed hash table is a protocol. It's like a hash table. So hash table, you have the index, you have the data. Okay, so distributed hash table is a hash table maintained by a distributed network or a peer-to-peer network. Okay, in a distributed way. So in this way, you can locate the data you have. Okay, so yeah, so that is the IPFS. What you just said. So another example will be another example of structured network will be, for example, the Bitcoin or Ethereum bootstrapping node. So for bootstrapping node is also due to the protocol. Okay, whenever you are connected to the Bitcoin or Ethereum network for the first time, you will be connected to the bootstrap node. Okay, and you will request the peers or the nodes that are in such a network, and then you will be connected to such nodes. So the bootstrapping nodes will be somehow infrastructure of such structured peer-to-peer network. Yeah.
Okay, so bootstrapping node is that must be a part of any structured P2P network.
Yeah.
So
it's not necessary for all the peer-to-peer network, but it is necessary for some structured peer-to-peer network. So if there is no bootstrapping node and no index node, what we have mentioned before, the index node. So these are all the infrastructure in addition to the peer-to-peer network. So when we have some additional infrastructure or additional data structure like the distributed hash table, so it will make such a peer-to-peer network structured. Okay?
Okay, thank you.
Yeah.
And any example of unstructured P2P network?
Just now I mentioned the ad hoc network. So when your computers are connected in an ad hoc way, and it will be unstructured. And wireless sensor network, okay? Wireless sensor network, due to the battery limitation, so the wireless sensors may be connected or disconnected from time to time. So it will need an unstructured network. Yeah.
Any application in the world like?
Wireless sensor network, I have to say. So for example, the structural health monitoring, like you have a building or a bridge, and you would like to monitor the health of such infrastructure, health of the building or health of the bridge, then you need to deploy the sensor network. Okay, a lot of, for example, vibration sensor, the sound sensor, speed sensor, etc. And such sensors will be connected in an unstructured way because the sensors are unstable. You cannot anticipate that all the sensors will be online all the time. So it needs an unstructured peer-to-peer network.
Okay, yeah, thank you.
Yeah. So first.
Hi. So the example of unstructured could be a very famous game called Among Us when played on local, and Counter-Strike when there's a local server. So both are unstructured.
Yeah. Thank you.
Hello.
Yeah.
So It's about the efficient search operation. So, like you mentioned, in the structured P2P network, it is more efficient in the P2P. So, but in the P2P, since it's peer-to-peer, right, it has to be fastest, right? Because if I'm making a search or if I'm making a request, it will go to the nearest node, right? Instead of like hitting to the central server in the case of a structured network, right? So, don't you think like in the unstructured P2P network, the search has to be more efficient than the one which is in the structured one?
So you mean in unstructured? So you mean unstructured peer-to-peer network
Yeah.
need a central server to perform the request?
Yeah, I mean like P2P, since you are able to connect to the peer network, right, peer node instantly, right? So the search has to be much faster than the one which goes through the central network, right? Comparatively, like.
It's like a coin of two sides. So suppose your neighbor nodes has the data you would like, then the efficiency will be higher, okay? But when all your neighbor nodes do not have the data you would like, then you need to go to the nodes that are two, I mean, you need two or more, three, four more connections. So
But in peer-to-peer also, like most of the nodes, they have the copy of the similar kind of data, right, across the network.
No,
So
yeah.
you connect to the nearest one to your node, and when you make a search, it goes to the nearest node and can get the information from there instead of like traversing all the way to the central server and getting the information from intermediate nodes.
Yeah, I have to say, first, not all the nodes have the replica, all the data. So it's not like blockchain. So for blockchain, of course, we have the full nodes that has all the blocks and the transactions. But in many other peer-to-peer applications, so just now we have the LimeWire, we have the Capster, etc. So not all the nodes have all the data. So for example, we are located in Hong Kong, and I'm requesting a data that only a node in Europe has such a data. Then you need a lot of loops to get the data transmitted to myself. So it will take a longer time actually. So because in central the server client server model, maybe there will be a server in Asia Pacific area. So we do not need much time for the data transmission. Yeah.
Okay, thank you.
Yeah. It's also for blockchain network. So not all the nodes are full nodes. Like there are some lightweight nodes that have stored only the block headers, and when you are requesting some data, you need to go further. Yeah. Okay. That will be the difference between structured peer-to-peer network and the unstructured peer-to-peer network. Okay. I have to say, modern peer-to-peer application will be structured peer-to-peer network because certain infrastructures will be demanded to enhance efficiency. And regarding privacy, structured peer-to-peer network, the data location is predictable due to structured organization. So it's like when we are employing distributed hash table, we can always locate the nodes that own that have stored a piece of data. But for unstructured peer-to-peer network, it enjoys greater potential for anonymity. So it's just like what we have mentioned, the wireless sensor network. Okay, so the data collected by which node can be anonymized. It has great potential for anonymity. It's unstructured. And regarding discovery, it's also very important function of our current blockchain system. Like we always say, the bootstrapping node in Bitcoin and Ethereum. So that is for peer discovery. So how you can connect? So for example, when you are joining the Bitcoin network using a software, and how you can connect it to the Bitcoin network. So that actually needs a peer discovery mechanism. So first, you will connect it to a peer. Okay, we will connect it to a known peer. So that is that it is always in the Bitcoin network. Then you will ask the peer for a list of their known nodes or known peers. So it means I will ask Alice, which other nodes are inside the Bitcoin network. And then I will connect it to the random subset of the peers from the list. So for example, Alice told me that Bob, Emma, Cindy, Jack are in the Bitcoin network. Then I will just choose a subset of the peers. So for example, I will just choose Cindy and Emma to be connected to. And I will repeat steps 2 and 4 and 3 until that I'm satisfied with the number of connections. So it's because when the number of connections, when you are connected to more number of nodes or more number of peers, then the security will be better. So you cannot be manipulated by any of your neighbors anymore. And also you can get some data faster. Okay, you can always choose your faster neighbor to ask for the data, to request some data. Yeah.
Can this theoretically, like a government, for example, does censorship all the IPs and like have a background task that connects to these IPs and then like censorship all IPs from this network?
So do you mean such a peer discovery mechanism will always make the network connected?
So like this discovery, there is a list of peers that I can connect to initially, right?
Yeah.
And this is already known to everyone. So can just governments say that they will censorship this list, and then even if the list changes, they can continue on censorshipping like this the rest of the IPs?
Okay, so first, there will be a lot of bootstrapping nodes. Okay, so not just have 2 or 3 bootstrapping nodes in US or mainland China. So you have a lot of bootstrapping nodes all around the world. Okay, and they will just so the second thing, they will just provide the peer discovery service. So for example, they will just provide which nodes are inside the Bitcoin network, and such a behavior may not violate the regulations in different governments. Okay, so for example, they are just providing the networking services. So you can hardly say that they have violated the regulations. Yeah. So yeah, that's my answer. So you cannot just perform censorship to nodes in certain areas to shut down the network. You can hardly do so. So like in current Bitcoin and Ethereum, so it's very robust to different regulations, right?
Yeah, but other than like a regulation, if like a government that doesn't care about the regulation and just want to shut down a specific network, in theory, it is possible just to censorship all the IPs to this network, right?
Yeah,
then
exactly.
No one can connect from this country.
Yeah. So I have to give the example in mainland China. So they do not allow the cryptocurrencies anymore. Okay, so it's like you cannot mine the cryptocurrencies anymore. But still, there are some nodes inside in mainland China. So why? They are using some anonymity tools. So it's like the virtual network, yeah, onion network, etc.
Thank you.
Yeah. Okay, so yeah, that is the peer discovery procedures. Okay, so you can be connected to a peer first. So the peer will be something like the bootstrapping nodes in the network, and then you will be able to know a list of nodes that is connected to the peer you know, and then you will randomly choose a subset of the peers from the list to be connected to. And okay, so another question: are there any applications of? So I think this such a question was answered by you. Okay, so I would like to ask for the applications of structured peer-to-peer network and unstructured peer-to-peer network. But of course, we are talking about the widely censored network. That is particular WSN for structured health monitoring. We have the IPFS, such as storage or data infrastructure. We also have the cryptocurrency. We have the media sharing system, like music and the video sharing system, etc. So these are very representative applications of structured and unstructured peer-to-peer network. And the initial discovery is also, so we talk about the peer discovery mechanism. So we say that when a node is going to join a blockchain network or a peer-to-peer network, it is demanded to be connected to a particular peer. Okay, so which peer should such a node be connected to? So we need the initial discovery mechanism. So that is always a boot node or bootstrapping node, or of course, such a mechanism will be covered later, okay? Covered later in this blockchain academy. And I would like to echo the attacks to peer-to-peer network or blockchain system. So yes, there are some attacks to decentralized peer-to-peer network. So suppose our attacking target, so we have the attacking target, how we can attack such a node. So do you have any idea? Yeah.
Well, we could always deploy some sort of like worm malware where it actually crawls through the network itself, infecting each of the nodes.
Yeah, exactly. So that can be one approach, but one attack. But that attack will be also exist in centralized system, I have to say. Yeah?
Sure.
Yeah. And if you are talking about decentralized peer-to-peer network, so any target will always have some neighbors. And what we can do is to attack their neighbors or fake their neighbors. I mean, make their neighbors to be all from myself. So in this way, we can attack the target. So for example, such a target node has 3 neighbors, and I can. It is possible to make the all the 3 nodes to be owned by myself. Okay, so in this way, I can attack the target. It's also called Eclipse attack execution. So what does it mean? We can flood a target node with a bunch of malicious peer address. So it means when a target node is connected to the network, I can inform him or her a list of malicious peer addresses. Okay, like when Alice was connected to Bitcoin network, and I am the bootstrapping node. I can say that Bob, Emma, Cindy are also in the network. And when Alice are connected to Alice, Cindy, Bob, if Alice, Cindy, Bob are all from the same person, okay, are controlled by the same person. So in this way, Alice can be attacked. It means so the messages sent from Alice can be swollen and can be neglected, etc. And the targeted node then stores these malicious peers and utilize them when resynchronizing on the next boot up. So it means when Alice, so I just say Alice was connected to Bob, Emma, Cindy, and whenever Alice has a new request, for example, Alice has found a new valid block, or Alice would like to synchronize from the current blockchain, Bob, Emma, and Cindy can always collaborate. I mean, they are from the same stakeholder or the same attacker. So they can mimic some fake messages and send such messages to Alice. So in this way, Alice will be synchronizing some wrong blocks. And the DOS targeted nodes to take it offline to force a resynchronization with these new malicious peers. Okay, so it means whenever I'm controlling all the neighboring nodes of Alice, I can perform DOS attack. Okay, I can send a lot of messages, unrelated messages to Alice, so that Alice can hardly, send a lot of messages to Alice beyond Alice's processing power. So that will be the Eclipse attack execution. So Eclipse means it will be kind of a circle around the Alice to attack all the neighboring nodes of Alice. And of course, besides the attacks, we can also have some countermeasures to prevent the attacks. So some countermeasures include restrict the inbound connections in some way. Okay, so it means I can always limit the number of connections of myself. I mean, from the same peer. Okay, when Alice is asking. I mean, if I'm asking some connected peers from a bootstrapping node, and the bootstrapping node has given me, so for example, 5 connections, I can limit the number of connections to 2 or 3. I mean, not all from the same bootstrapping node. I can ask some other bootstrapping nodes. And there can also be some random selection of peers to connect with, okay? So just now I say we have 5 bootstrapping nodes, and I ask each of them for 5 peer nodes, connected peer nodes, and I will select 2 or 5 from each of the bootstrapping nodes. So in this way, I can be connected with 10 peers, but they are randomly selected from the 5 bootstrapping nodes. And there can be some deterministic node selection. So there it can be some nodes. The node selected, I mean the peers I am initially connected to, can be some nodes with very good reputation, like the nodes written into the Bitcoin software. Okay, so some very famous nodes. Okay, but also it will be based on reputation. Okay, so you can hardly say that such a node will be always reliable. But deterministic node selection to select the nodes with higher reputation will always will decrease the chance of being attacked. And we can also restrict the new nodes. Okay, and it means whenever a node asks me for new connections. Okay, so for them, so in peer discovery mechanism, I can always send send my connected peers to my neighbor. But my neighbor can restrict the new nodes to be connected. Okay, it is also a measure to prevent the attacks. And of course, such an approach is probably not what we want, because we would like the network to be decentralized, and the connection should not be very static to decrease the centralization degree of the whole network. Okay? Yeah, sure.
Okay, from previous slide about the DOS attack. I have a question. If I bring up a validator in my home and someone, a malicious attacker, wants discover my IP, he could then flood my connection with a lot of UDP messages, DOS. And then I could not sign the messages, and I could get a penalty and get slashed. And what you say is that then I need to have at my home a firewall to prevent this kind of attacks. So it's not a good idea to have a validator at home.
So sorry. So you mean that someone else will use my IP address to fake some messages? Mm-hmm. So first, so the current network infrastructure will avoid such a faking approach. Like when you are sending a message out, you are the attacker and you are sending some message out. The current internet infrastructure can recognize your IP address. Okay, so that will be the first thing, and of course the second thing, others can regard you as an attacker. So when you are faked by many other nodes. Okay, so it is possible to attack the nodes in such a way. Yeah. So if the faking method really works. So yeah.
Okay, so the IP address of the validators is not easy to get the IP address of the validators. Is what you say?
Yeah.
Okay.
Yeah.
Potentially, an attacker could sniff the port, and if our nodes use a specific port, I could guess that it is a validator node, and then I'm a competitor. I want to DDoS these nodes, and the attack is relatively done.
So you mean?
So as a validator, you have to be, acknowledged with the DevOps skill and all of these things that make your validation safe. No.
So you mean the number of connected peers can be predicted by some attackers?
But I mean, the peer is the data go through some specific port, no, to a peer. It's not a random port. It's always the same port, isn't it?
Yeah.
Oh, so if I know that your node, your IP is using that port, I could DDoS your IP address. So
Yeah, yeah. So
pointing to the question to my colleagues is if you run a validator, you need to be aware of this kind of attack. You need to have a firewall, you need to have a specific knowledge, you need to be probably a DevOps skill. It's not like, oh, let me spin up a node.
Yeah, yeah. First, I have to say the DOS attack is aimed at the whole network, should be aimed at the whole network rather than a specific node. Okay. So, for example, if I, for example, in the Meta or X, okay. So, if I would like to attack such an application, I can just attack the servers of Meta or X. So, it's very simple. I mean, not simple, but it is possible. But in a peer-to-peer network, so if you are just attacking one node, so it is meaningless, okay? So for example, if you are attacking a node that you do not know, you can hardly gain anything. So you do not have the motivation to perform such thing.
If you are staking reward, if your skin is on the node and then you DDoS and then you lose the dots that you invested in.
Just so I think what they're getting at is like that it's getting into block like leader election, like what, like maybe you want to DOS the block producer in consensus, but not to cut in too much, we will talk about leader election, and that's why in consensus systems we have mechanisms to not let you know who's next. Basically, I don't know if that's where you were going, but. Yeah, maybe that's where you're going. I was just trying to. Yeah. He also knows a lot about consensus, but we don't want to spoil it for tomorrow. So.
Yeah. Exactly. I'm talking about the networking, and for regarding consensus, of course, Actually, I was teaching a subject about distributed algorithms and protocols for blockchain system in this semester. So if you like some more knowledge about consensus, I'm happy for offline discussion. That's all for this, I have to say, discussion or lecture. So the conclusion will be the peer-to-peer networks offer us a path forward towards applications which are more decentralized and censorship resilient. Okay, so censorship resilient like the public blockchains, and decentralized such public blockchains can not be manipulated by any stakeholders or organizations. Okay, and is also a foundation of blockchain technology. Okay, thank you.